or not, okay? Tell me if it's better or not better. So, I mean, it's up to you, but this way I can record the whole class, and you can have the video at home. You can watch on the video again when you need help. Okay, in the previous class, we have introduced find the length of an arc. Today, we're going to continue. So, the length of an arc. Oh, you can choose that. Is L equals from A to B square root of 1 plus f prime of x square dx. Okay. Well, in the future, because I have not prepared that yet, but from next class probably I'm going to prepare a Word document and type in all the problems well before the class. Then we don't have to type in so many things in the class. I don't have to write in so many things, but instead I can explain more or look at the problems. Does that make sense? And then you can print out the class notes and bring it to class, and you have the space in the middle. You can take notes. You don't have to copy those problems as either. And because you can print it out, those already there, right? Like the class notes. So by now, is that looking better? Is that better, clear than the dot camera? You see. So today we're going to look at the surface area. So area of a surface revolution. You see, if I write something wrong, I can get rid of it. Okay. Is that better than the dot camera? Is that better, everyone? Oh, it's better. Okay. So if we have the surface area, for example, we have something like this. Okay. Okay, in the middle, if this is that. So the surface area is from the lateral surface area of the frustum of a right circular cone. Okay. I can move that a little bit. It's pretty much the same like the previous one. So basically, how do we find the area of this one? When you look at a just a picture like this, okay, small one, like this. We're looking for we want to find the surface area of this one. For example, like this. We want to find the surface area of this. The surface area of the lateral surface is going to be 2 pi r times L. This is L, okay. But the middle R is if this small circle the R is R1. If the big circle the radius is R2. Now if we do 2 pi RL, if you see previously when we look at a cylinder, the surface area, just the siding surface area, is 2 pi r times h. This is r, this is the h. That's what we have before, right? And this means this basically have the r, the top and the bottom, the r are the same. So we have 2 pi r times h. Does it make sense? So if you open this lateral surface, you're going to have something like this. How do you call this? Trapezoid? Is that? Yep. Okay. So basically, you have the surface area like this. If you open this one, you have a surface area like this, like the trapezoid. So it's 2 pi. You have this is R1. Sorry, the whole thing, the length is 2 pi R1. The bottom one is 2 pi R2. Okay. Can you see it very clear? Okay. So the bottom one is 2 pi R2. And then the area of trapezoid is S equals 2 pi R1 plus R2 and over 2. Okay. Times this actually is h, but for here is this L is the same as this height h here. Okay. So now, if I look at the previous one, we can break this surface surface into a lot of small lateral surface like this. So basically, we're going to break it down into very small one, a lot of small ones. Okay, small ones like the like this one. We break this one. If you zoom it out, it's pretty much like this. Okay, small one. Now, if we break everything down into small lateral surface, then we're going to have the delta S. Maybe just use the black color back again. So we have delta S equals 2 pi times the Ri, which is the middle R, okay, times the delta Li. Delta L is this small r here, this small r, this small L. This is delta Li. If it's very small, it's going to pretty much like a very, very small lateral surface. Okay. Now, if we add everything together, it's going to be S. Okay. Well, delta Li will have to change that delta Li into delta X, because when you take the derivative, it's dx or dy, right? And we have that. We can continue. This equals. Oh, sorry. This L is we haven't learned that before. This L is what? Is the arc length. Okay. The arc length is square root of 1 plus square. If you do that, square root of 1 plus f prime. The L is here. Previous section we learned that the length is L equals a to b square root of 1 plus f prime squared dx. So we basically just plug the L into here. It's the same L. It's the arc length. Then we have our surface area. It equals two pi from A to B. R is same Rx. You take the antiderivative, right? And then the length is 1 plus f prime square dx. Okay. From the delta S is just small one. You take the antiderivative from A to B. So it's 2 pi R times L. L is the square root of 1 plus f prime dx. We did that before. So this is the formula for the surface revolution surface area. Or we can do y direction as well. S equals 2 pi from A to B Ry square root of 1 plus f prime y squared dy. Okay, this should be the same thing as that one, but just a different direction. Okay, so now let's look at an example. What I said is, next class part, I'm just print out type in the Word document, the example word, like this whole thing, set up the whole thing, that whole problem has been typed in the Word document. Then I'll leave a big space for you to write down notes. And then I don't have to, in the class, I don't have to write down this word, set up and evaluate. the definite integral. All the class has been recorded right now. You can go to YouTube and watch it yourself at home as well later after class. Okay. Set up and evaluate the definite integral for the area of the surface generated by revolving the curve about x-axis. Okay, set up and evaluate the definite integral for the area of the surface generated by revolving the curve about x-axis. If we're given the equation is y equals 1/3 of x squared, x cubed, sorry. Okay, so if we're given that and revolve by x-axis, give this is the equation, and if it's revolved with respect, rotated with respect to x-axis. So first we need to graph this picture, graph this function here. If we graph it, we're going to have like this. Okay. And if we rotate it this way, we rotate it, you're going to have something like this. Okay. You rotate here. The green part is the surface area, is what we're looking for. It's much better, right? And you have the have different colors to show you. You rotate it, you have this is y equals, this is the line here is y equals, wait, I have to change that. Why did I change this? So y equals 1/3 x cubed. That's the function for that curve here. Then we rotate that with respect to x-axis. You see, it's very clear, very straightforward. Okay. So now we want to find out the area. This is given to from 0 to this point. From 0 to point 3. Plug 3 into here, 327. So x goes to 3. Okay. So just the point 3 here. Okay, so now we want to find out from 0 to 3. I'll give you 1 minute. You can try to set up this one yourself and see if you can finish that one. To set up on the model. You have the previous formula I gave you. Technically it's better. That. Okay, so now this is the formula we're going to use. S equals 2 pi r. Take the antiderivative from a to b times the height. A height is kind of pretty much that. We kind of like consider that as a height. It's not really a height. 2 pi r times the length of the L. So take the antiderivative. Okay, so now we plug everything in. So first I have a question. What is r here? You said what'd you say again? Please say again.
Would the radius be 9 if you just plug in the 3 to the equation?
Well, the because if x change, this r should be a function, right? At this point, the r is 9. What about this point? So the r is actually changing all the time. When you think about here, you have a lot of circles. You basically cut that everything for small pieces, and here you have another radius. Basically, you have very small here, and the r is changing. This one is changing to a small one, to this one. Does it make sense? If you look at the middle, you have something like this, and your r is going to be just like here, right? And here the r is like that. Well, it's a small piece here, and r is 3. You're right. R is 3 for this one, for the base, for the right top, the right one. But in the middle one, the r is changing. So what is r? 1 over x3 cubed. Very good. The r for every point, the r actually just the y values. For each point, the r is just the vertical length. Okay. So for each point, at each point, the r is the y values. Okay. So this is a r for the radius for this circle here. All right. So it's 2 pi. R is 1/3 x cubed. Very good. Now, given that the function is 1 plus f prime, f prime is easy. The derivative of x cubed is 3x squared times 1/3, which is just x squared. Okay. From here we got the y prime, which is x squared. That's the easy one. And then square again. Then we do dx. And now I have another question. What is the boundary? 0 to 3. Thank you, Lacey. Okay, so now we just need to finish this antiderivative. And then we can 1/3 multiplied by 2 pi, can take it out. 2 pi over 3 from 0 to 3, and x cubed 1 plus x power 4 and dx. Okay. And then this here, we can use substitution, or we can do an easy way. See if I'm going to write this way, see if you understand it or not, okay? So 2 pi over 3 from 0 to 3, square root of 1 plus x4, derivative of 1 plus x power 4 over 4. If I write this way, does it make sense to you? Yes? Yes or no? Where does this x cubed go? It goes to here. These two together comes to here. Do you know why I do this? Okay, I'll just finish it right here. I'll just continue here. I'll just stop here. Okay, next let's see what I'm going to write is like this: 3 to 3 and 1 plus x power 4 raised up to, this is 1/2 power, so it's 3/2 power over 3/2. And so after I take the antiderivative and then just plug 3 and then 0 in. Okay, then plug it in, you get a final answer. Okay, so it's going to be in the end you get the whole thing is the same. You got 258.85. Okay, so let's just leave here. I'll do right here again for the antiderivative for this part right here. Okay, just a different way you can say it. 2 pi over 3. Question?
I wanted to ask.
Yeah, I'm going to do here. Okay, so now I think if I do u substitution, you're going to make it make sense to you. So what do we need to do? Net u equals x power 4 and du equals 4x cubed dx. Does that make sense? Yes? Okay, that's what you do normally. But here is the same idea actually. I prefer if you do more, you can do it easy way like that. So 2 pi over 3, and if you change the u, if the x is from 0 to 3, you're going to have u is from 0 to 81. Sorry, x4 plus 1, that would be better. It's x from 0 to 3. You can change that in 1 to 82. Does that make sense, everyone? You substitute the whole thing, 1 plus x4. And then you change the boundary from 1 to 82. And then you have square root of u. And the dx x cubed is going to be from this one, you got dx. Okay, so x cubed times dx. dx is du over 4x cubed. And x cubed cancel out. So it's going to be 2 pi over 3, 1 to 82, u to 1/2, divided by 4. Oh, I have to take 1/4 out here. There's 1/4, I think. Because I take the 1/4 out, I have to. So 1/2 divided by 4 and du. Not bad. You can use the same color. So this way looks better. Yes or no, everyone? U substitution?
Yep.
Okay. So u equals x4 plus 1, du equals 4x cubed. The x cubed, you look at it here. The x cubed and the dx together, these two can make the derivative of x4. That's why I do that's why I take the u substitution, then you cancel that out. Because x cubed dx actually is the derivative of x power 4, and divided by 4, the constant doesn't matter too much. And then you have 2 pi over 3, and then this is just the 1/4, and multiplied by u 3/2 divided by 3/2. Plug 182 into that. Okay. So if you compare this one with the other one here, if you compare these two, it's exactly the same thing. You plug 3 into here, it's 82. You plug 0 to here, is 1. And everything else is the same. Okay. And now you just plug it in. It's not really a hard question. Then you just use a calculator, plug it in. You got the answer is 258.85. So Lacey, do you have a question? Okay. So these are basically the same. What I do here, I just make up something, put this as a u substitution, just do the u substitution here. The u substitution for this one, the right hand side one. In the future, I'll do more and more on this way. You're going to learn better. The more you do, you're gonna feel like, oh, that's how you do it. You don't have to do the u substitution again because it really takes a lot. Sometimes it's a little bit time consuming. But if you're familiar with that substitution method, it's going to be much easier. Okay. So next one. We can look at one more example. and set up the evaluate. You see set up, and this I will type in the Word document before I come to class next time. Set up and evaluate the definite integral for the area of the surface generated Mr. R by chapter 8. We don't have so many word problems anymore. Just to do a lot of antiderivatives revolving the curve about the y-axis. Okay, the function is given as like this: y equals 9 minus x squared. Well, if you draw the picture, it's going to be like this. 9 minus x squared is a parabola open to the left, so a parabola open downward. Okay, so basically we are just looking at this part. Okay, from 0 to 3, just that. And we revolve it with respect to y-axis. Just make a different color here. Revolve with respect to y-axis. Then you're gonna have something like this. Like you're looking for the surface area. Okay. The surface area, the green surface area is what you're looking for. So basically we use that we can use that. Oh, my bad. How to get back? Uh-oh. Let me just do it again. So basically have this, and you have this. Okay, so what do you have is in the middle. You always break that down into a lot of small lateral surface, and also we use that take the antiderivative from 0 to 3, 0, and this is 3, 0, and this is 0, 3. Okay. So given y equals 9 minus x squared, then we want to find the surface area if you rotate it with respect to y-axis. Want to find the surface area. And then we are going to use the formula the same formula, s equals 2 pi a to b r times square root of 1 plus f prime of x and dx and square. Okay, I'll give you 2 minutes. You can try this by yourself. Okay, so S here, 2 pi from 0 to 3. R for each one is just the x. For each base area, so just the x. The r, 2 pi r, you see? It's just the x value. From here to here, it's just the x, right? So it's 2 pi x and times r, 2 pi r, and times the length is 1 plus the derivative is negative 2x and square and dx. Okay, so you have s equals 2 pi 0 to 3 x 1 plus 4x squared dx. It's the same thing as the previous one again. You do the antiderivative, do u substitution, and let u equals 1 plus 4x squared, and then that. Okay, so I'll just do u substitution. That's what you do usually. Don't want to confuse you. So u equals dx and du equals 8x dx, and then x is from 0 to 3 and u is from 1 to 37. Just plug in, and then our integral is changing to 2 pi from 0 to 3, and then x dx, from here x dx is du over 8. Okay, so just look at x dx here. Okay, so x dx equals du. First is the square root of u. Okay, and x dx is remaining. What remained is going to be du over 8. Okay, from here you got this. From here you got x times dx is du over 8, and the square root of 1 plus 4x squared over u. So now it's just a very simple polynomial antiderivative. So s, not bad. So s equals 2 pi. You can put the 8 in front of that, just coefficient, and it's u 3/2 divided by 3/2. You add 1 on the power, so u to 1/2 power. 1/2 plus 1 is a 3/2, and divided by 3/2. And plug into 0 to. Oh, I think I need to change that boundary. Sorry, 1 to 37. And then plug that into this here, and then s equals plus 3.119. Okay, your homework you can try. I changed the homework twice. You have more tries than before. The maximum limit is not 5 times now, it's more than 5 times. You can try a lot of times. Okay, at least 10 times more, so you don't have to worry that. And also in the test, I'm not going to be that picky on the last point. As long as you get this above, for example, if you got this one here, right, the last one probably got 116, then I probably at most mark off 1 point if it's 10 points problem. I'm not picky professor of just look at, oh, the last answer is right, but all the previous, for example, from here to here is right, and just the last one is wrong. That's fine. I'm not going to give mark off a lot of points. Maybe at most 1 point over there, okay? But if you have to make sure before the last step the answer is right, okay? So that's for this one. In your homework, I believe the last 2 problems of the homework is a surface area problem. Have you all finished it? Barbara campus students, have you all finished the homework, last 2 problems? Yes or no? Okay, that's perfect. All right, so now let's continue with 7.5 work. Okay, 7.5 work. If you have any if any of you has taken physics before, I think you have the idea about work. Okay. If you're engineering department, you're going to do that a lot in the future. So work done by a constant force. if an object is moved a distance d in the direction of a applied constant force, F, then for example I'm going to type in all of this word in the Word document, then we don't have to write down this. Then the work down by, I don't need that, by the force is defined as W equals F times D. Basically the force times the distance is the work, okay? And if we use the integral, it's going to be from A to B. Sometimes you see the F could be a function of X with respect to the X. The F can be changed, not a constant force. The F will change. So it's a function of F, a function of X, and the D, a distance, is a dx, is not a, is changing with respect to x. So distance is not fixed distance, and is you take the antiderivative, take the integration to find the distance. Okay, so that's what we do for the work. Okay, in the physics probably use more of W equals F times D, just multiply them, that's it. But now if the force is changing, then you have to use this one. Okay. And also the Hooke's, I think it's called Hooke's law, is about a spring. A force required to compress or stretch a spring is proportional to the distance d that spring is compressed or stretched from the origin length. Okay. So Hooke's law, the F is changing, is equals K times D. Okay. The K is a coefficient. K is a coefficient, or a it's given. The K will be given as a constant of the different strain. So different spring, you have different coefficient for that. So you compress the spring or stretch the spring, you need some force to do that. The force is proportional to the distance. Okay. Let's look at an example. A force of 750 pounds compresses a spring 3 inches from its natural of 15 inches. So natural length is 15 inches for the spring. Find out the work. Find the work down in compressing the spring. Additional 3 inches. So a force of 700 pounds compress a spring 3 inches from natural of 15 inches. And find the work done in compressing the spring in additional 3 inches. So we know that the Hooke's law is given here, F equals K times D. Okay. We also know that work is given as W equals A to 3 Fx times dx. Okay. So now, first we know that this Hooke's law, we don't know the spring coefficient is not given. Okay, for the K. K is not given here, but we can find the key first. First we need to find the key here. We need to find the key. Okay, so that's not given. So F, first F solution. We know that work equals from A to B F x times dx, right? That's what I have. But for this one, it's a spring. You compress the spring 3, the additional inch you got is actually from A to B, you have to use the K times D and distance times dx. Because that's what I given to you, F equals K times D. You plug it back, plug the Hooke's law here is like this. But the K is not given. The K is not given, okay? Let's just draw a picture for that. Like this, the spring. You have compressed it. The previous is pretty much like this, like 15 inches. It's here, okay? Previously have 15 inches. Now, and it's compressed spring. Compress the spring 3 inches from natural of 15 inches. So this is one. Compress that's, oh my bad, I should probably draw a little bit more. So this is compress the spring 3 inches from, okay. Okay. So now we have the force is given 750 pounds equals, and K times D, D is 3 inches. Okay. Then we got, from the Hooke's law, we got K equals 250. Okay. Now once we find the K, we just need to plug it back into the equation here, the work. So work W equals from 250x, we know that is 250, and D is your x direction, so it's x and times dx. Okay. So now the boundary. What is the boundary? My question, what is the boundary? Can anyone tell me what is the boundary here? Well, the work is A to B K Fx dx. The formula is not hard at all. The formula is not hard, and once you find a K, plug it in, is not hard. D is just the x direction, it's x. So my question is, what is the boundary? You can draw the picture. If I draw this one, you probably can feel a better way. Okay, put it in the so this is the original point from here, and it compresses 3 to here. Oh my God. So now it's here, and then you want to compress into here 3 additional inches here. You compress a little bit more. This is 15. And this is now is 3. You want to do 3 additional inch. This is 0. So now you want to do 3 additional inch. So what is the boundary? Anyone? This is the boundary. So additional 3 from 3. It's from 3 to what? To 6. Does it make sense? Okay. So you got this equals 125 x, sorry, 250x is 125x squared. Take the antiderivative. Then plug the boundaries in 3 to 6. The final answer is going to be 337 inch pounds. Okay. So we're going to stop it here today, and tomorrow we are going to continue finishing the 7.5 the work, and I will type in the problems. I upload those Word document to D2L. Before you come to the class, you can print it out. Then you don't have to write down so many words. Like take notes. Just bring the notes back into the class, and you write in the space. Okay. I'll upload the notes before 5 o'clock today. Because it's a little bit more work. I just type in the word for the problem. And also this class is available in YouTube. I will post the link, the YouTube link into your D2L work. I'll just post the link there, okay? So I'll see you tomorrow. Let's see.